We're going to begin starting our lessons with the SAT strategy session. Give me a second to mark this so I know which one it is. We're going to do that so that you can start seeing some strategies that can answer SAT questions, multiple choice questions. We'll start off kind of easy, and hopefully by the end of the year we can put some nice ones in front of you, and you'll have the confidence after looking at it to kind of say, hey, I think I can handle that stuff, because it's really not that bad. And again, multiple choice questions, SAT questions, and ACT questions typically give you enough hints to try to figure out what to do. This question here says, on Saturday afternoon, Armand sent M text messages each hour for 5 hours. Tyrone sent P text messages each hour for 4 hours. Which of the following represents the total number of messages sent by Armand and Tyrone on Saturday afternoon? This one here, there are keywords in here that help us out. And what you have to keep in mind is that word each does the same thing it's always done, which usually means that we're going to take something and multiply it by a variable. And you're talking each hour for 5 hours with M text messages. Here's another each, which is P text messages for each hour for 4 hours, which means M and 5 should probably be related. 4 and P should probably be related. And the biggest key word here is that you are looking for the total number of messages. And typically whenever you're looking for a total, it means you're going to add to get that answer. Again, with a multiple choice test in front of us, it means that I can eliminate A and B because they do not have any kind of addition signs at all to indicate a total. And then what you see left over is two answers that are simple enough that if you look at them and say, hey, 5M, yes, because 5 and M go together, 4 and P go together. Notice this has 4M, which means it cannot be D. My answer has to be C. Keep in mind these questions are going to start becoming part of your quizzes at the end of the week, so make sure you're at least paying attention to what the strategy is, because that's where I'm going to get them from. Today we're going to look at chapter 5.5. There are two main formats that we'll see for an equation of a line. The first was seen last week. We called it the slope-intercept form, which is y equals mx plus b. This form we were given the slope and the y-intercept, which is why they called it slope-intercept form, and that assisted us in graphing. Today what we're going to do is work with the standard form of a line, and the standard form is written with x first, y second, and then it equals a constant value. The general format is as follows. So you'll usually see something times x plus something times y equals some number. Again, here A, B, and C have no true meaning. They just do that so you understand there might be a number here, might be a number there, and there's going to be a number over there. So in this form, again, as I said here, there's no true meaning. It's more important to notice that the placement of the pieces with x and y on the left and the constant on the right, compared to a slope-intercept where y is alone on the left, and that is how you're going to make the difference between the two whenever you get ready for your test. There are three main points to today's lesson. The first point covers how to identify the intercepts. The second point is going to cover how to use the intercepts to graph, and the third point is going to cover some special graphs that are encountered whenever we deal with standard form. So let's get to the first point of the day, which is finding the x and y intercept. This says here that the general rule of finding an intercept is to plug in the value of 0 for the opposite letter. For example, if we want the x-intercept, then we plug 0 in for y. You might want to write that down for yourself because that's important. Conversely, if we want the y-intercept, then we will plug in 0 for x. So look at the following question, and I'm going to work that out for you. Again, you might want to put this in your notes so that you have something to kind of guide you. 5x minus 4y equals 20. They want the x and y intercepts. So what I do is I've labeled the fact that I'm looking for my x-intercept. I then think about the fact that if I want the x-intercept, I plug in 0 for y. And so I write 5x minus 4 times 0 equals 20. Keep in mind that whenever I multiply something by 0, that it gives me an answer of 0. And that pretty much disappears, giving me just 5x equals 20. And when I go to solve that, it means that my answer is x equals 4. Again, the x-intercept is x equals 4. Notice I'm looking for the x-intercept, and my answer was an x. When I go to find my y-intercept, I label it. I keep in mind that if I want the y-intercept, I put 0 in for the opposite letter, which is x. So I write this now as 5 times 0 minus 4y equals 20. 5 times 0, of course, turns into 0. And the part where they're expecting you to mess up is that when this 0 goes away, this negative still belongs to negative 4y. And so you have to keep that in mind. And of course, we're good enough to know that if you divide this by negative 4, that y is negative 5. X-intercept is 4, y-intercept is 5. That's all you have to do to find your intercepts. It says, notice that plugging in 0 for a variable inevitably makes the variable disappear, and this is why a more advanced idea of finding the x-intercept is to simply ignore y. Just like finding the y-intercept is done by simply ignoring x. Let's look at some questions briefly with this advanced idea. Now, if this doesn't work for you, just go back to the first way I did it. But I think that if you do this the way that I'm talking about here, if you learn how to do it this way, that it's going to help you out a lot. So looking at this problem, 2x minus 7y equals 14, looking for the x-intercept means I'm going to ignore y, which means I'm going to rewrite this as if y does not exist. It means the 2x gets written. The 7y has a y on it, so we ignore it, and we set it equal to 14. We simply solve that to find out that x is equal to 7. Think about what would have happened. We would have had 7 times 0, which was 0, which would have went away anyway, so we just got that out of the way early. If we were looking for our y-intercept, again, the best way to do that is to simply ignore x, and so we rewrite this formula by ignoring anything attached to x. That has an x on it, so we ignore it, but we do put minus 7y and 14. Again, we're good enough here to recognize that we divide by negative 7, getting the answer of y equals negative 2. X-intercept, y-intercept, that's all. Looking at B, find the x and y-intercepts of the equation. Again, if I want the x-intercept and I apply the more advanced way that I showed it to you, I will ignore y whenever I do this, so I'll have x get written, 2y gets ignored, equals 10. Notice that that's my answer. That's it, because x is already alone. When I go to find my y-intercept, I ignore the x, but I write negative 2y equals 10. I divide by negative 2, getting the answer of negative 5. Here's my x-intercept, here's my y-intercept, and that's all you have to do. Now this is important because of the second part of the day, which is graphing a line in standard form. And as it says, once you understand how to find intercepts, graphing is very simple. Keep in mind that the x-axis is horizontal, it's this one here, and that the y-axis is vertical. The nice thing about most graphs is that they label them for you. Notice you have a x here and a y here, so missing that is more a testament to not really working as hard as you could to find the information, but just be careful and again minimize your mistakes. So let's look at some examples here. It says to graph the equation 2x plus 3y equals 6. What we will do, recognizing that this is in standard form, is we will find the x-intercept first. Keep in mind, we're going to do the advanced way. If you need to do it the other way, that is fine, but I do it the way that you'll eventually be doing later on anyway, which is to say I'm going to ignore y, which means I simply put 2x equals 6, which means that when I divide by 2, x equals 3. Once I know that x equals 3, I go on the x-axis to where x is 3. Notice you have negatives over here, positives over there, and I put a dot where x equals 3. Very simple. Then I do my y-intercept. Again, to do my y-intercept, I ignore x, so I don't write that, but I do put 3y equals 6, which means, of course, that y is equal to 2. This is telling me to go on the y-axis to where y is 2. Notice your positives are up here, your negatives are down here, positive 2 is there. If you remember earlier last time I told you that you need a straight edge for this stuff, I think some of you missed points on your quizzes because you either drew lines that weren't straight or you drew lines that weren't long enough. You might want to make sure that you start paying attention to that part. But remember, I showed you that you can make a straight edge by simply taking a piece of paper, a scratch paper, and folding it a couple times, and now that gives me something to where I have to go all the way across the region. That was another area where people missed their points because they did not go all the way across the region. So again, make sure that graph goes all the way across, and that is it. That is your graph for 2x plus 3y equals 6. It has an x-intercept of 3, which is here, a y-intercept of 2, which is there, and that's all. If you are asked to graph 3x minus y equals 3, same thing. Notice that this is in standard form. Once you see it's in standard form, simply ignore y, and you end up with 3x equals 3, which when you divide by 3 you get x equals 1. Go to your x-axis and put a dot on the 1. Then I look for my y-intercept, which means I don't write the x, but remember this is a negative y equals 3, which means that y is negative 3, which means go on the y-axis to where negative 3 is, which is here. And once I have those 2 points, I now take a straight edge, whether you use an ID or something else. Just make sure that line goes all the way across that region in order to do it the right way. Another third one here. Graph the equation 2x minus 3y equals 9. Again, recognize that it is standard form because x and y are on the left with the number on the right. First thing we're going to do is look at the x-intercept, which gives us 2x, ignore the y, equals 9. Dividing by 2 here. I know I usually say I want fractions, but in terms of plotting, 9 over 2 does not help me, so let's do 9 divided by 2 and turn it into a decimal form. This is 4.5. And this is where we have to think a little bit. 4.5 is halfway between 4 and 5 on the x-axis, and so your first point should be here. Now, I do not expect you to put it exactly at half, but it definitely shouldn't be too close to 4, too close to 5. But as long as it's somewhere generally in the middle, I will give you credit. But if it's somewhere where you have a 4 here and a 5 there, and you put your dot way back here, I can't give you credit because that's definitely not 4.5. It has to be somewhere in that middle area there for you to get your credit. Anyway, if you're looking for your y-intercept, ignoring x, you get negative 3y equals 9, which means that 3y equals negative 9, and y is negative 3. So go on the y-axis to negative 3, which puts us here. And again, make sure your line goes all the way across the region if you want credit. I hope you listened this week because a lot of you did lose points on that. Please make sure you're understanding that I give you these rules for a reason, and that would be your answer. So that is point 2, which takes us to point 3, which is graphing some special situations that happen. You definitely want to make sure you take notes on this because this part here confuses a lot of people, and really the best way to get it is just to experience and mess up a whole bunch of times and eventually just start getting it right because you found a way to make the connection. There are 2 equations here that are difficult to grasp. These are graphs that only have one variable in them. The easiest way to graph these is to notice that the graph represents an intercept. Then make the best choice from there. Sounds very cold, but really that's all it is. Once you recognize that it represents an intercept, your best choice kind of comes from there, and it's really not as bad as what it seems once you understand that. So we're going to look at probably about 4 of these and see what happens. This part says graph x equals 4. Again, the part that I recognize is this is definitely not slope-intercept form. It's standard form, but it's not a standard form that I'm used to. But what it tells me, if you think about it, is that x is equal to 4. And I know that the x-axis is here and that the 4 is here. Once I have that, really, if you think about the mark that was on the 4, if I draw a line going this way, that's going to hit x equals 6, 5, 4, 3, 2, 1, negative 1, negative 2. But if I draw a line through here, it only crosses through 4, which is what tells me that this line should go here and actually be a straight up and down vertical line. And think about these points. The point on this is 4, 1. The point on this is 4, 2. This is, 4, 1 there, 4, 2 there. 4, 3 is there, and notice if you look at all these points that my x value is 4, and that's what that's telling you. So you could either use that way to do it and simply make a tree of 4, 0, 4, 1, 4, 2, plot those points and see your direction, or again you can use the intercept and go that way. Whatever it is, at some point you have to make sure you put enough work into this to get these down. I really don't think there's a reason to miss them outside of just, again, not practicing enough, because I think they're simple enough to understand once you put the work into them. The second one has graph y equals negative 2. And again, notice this is not, it looks kind of like slope-intercept form, but it's not because you don't have a slope, which is actually is a hint for some people. But the thing I recognize that it says y is equal to negative 2. On my y-axis, negative 2 is here. And again, in order to make this just negative 2, it means that my line should just go right through that. The way I used to think about it was the tick mark that goes through negative 2 goes this way. And so that means that my graph should also go the same direction. And so I take my straight edge, I draw the best straight line I can possibly draw, and I end up with that graph. Again, if you think about these coordinates, this is 0, negative 2. This is 1, negative 2. This is 2, negative 2. And so when you look at that, notice that all of your y's are negative 2, which is exactly what this told you. Again, there is no easy way to do this. You have to make sure that you go ahead and start doing some sort of memory tactics, practicing a little bit, and figuring out what works best for you, but you have to get that right. And it's going to take some experience. Graph y equals 3. Again, once I see y equals 3, y-axis to 3, I know that the tick mark through 3 goes sideways, and so I draw a line that goes sideways. Sorry, it's not on the graph here. And there you go. And then the last one says graph x is equal to -5. So again, I notice that this is an intercept. X equals -5 is back here. The tick mark that goes through 5 goes up and down, which means that I want my line to also go up and down. And that is your graph. Is there another way to do this? Not really. I don't even think your graphing calculator can do this because your graphing calculator is set to start with y. But just has to be something that you get right on that part. Now, for those of you who have not been watching your videos throughout the days, I have now started putting the bell ringer in the actual equation or in the actual video, and so this is your day's work. Make sure before you go to your MathXL that you do this bell ringer here. I am looking for the equation of the line passing through 4, 5, and 6, 11. And so after you finish your bell ringer on a small sheet of paper, hand it to me, and then begin working on MathXL. Good luck, and again, ask for assistance on anything. Keep in mind, again, you have to turn in your B work if you want credit. Good luck.